So in the first class last night, we spent a lot of time looking at various aspects of the sciences, seeing the stamp of our Creator. We quoted Paul from Romans chapter 1 when he said that God should be obvious to everyone simply when they look into his creation. By the observation of nature, we should see the stamp of our Creator. And Another one way to describe science is to say it's simply the observation of nature. So you could say that the Apostle Paul was saying that when we look into the sciences, we should see God there. And in the last class, we looked at evidence, powerful evidence, I hope, for the resurrection of Jesus. And now in this class, we're gonna go back to science. And we're going to look at math. And we're going to find God there too. I hope you'll see with me. And I wanted to start with what I think is a really great quote from one of my favorite Christadelphian writers, Brother Islip Collier, in one of my favorite Christadelphian books, Conviction and Conduct. And he says this: "The only possible conception of God is as the uncreate, the one great reality, the first cause. In point of fact, we are all bound to recognize the existence of a first cause or force in the universe. There can be no quarrel between philosophers on this point." So he says, no matter what your worldview, you got to agree that it all started somewhere. There must have been a first cause. We say either there is a God or there is not. And we only state the same truth in a slightly different way when we say either the first cause is an intelligent, conscious force, or it is a blind force. Incontestably, the truth lies with one of these two propositions, and what is true now always has been true and will remain so for all time. Sometimes there are more alternatives than one, and the negative may be taken to imply one of several affirmatives. Thus, the Bible is either entirely true, entirely false, or partly true and partly false. Everyone who denies two of these propositions must affirm the third. So when you think about that, you'll realize the truth of that statement. You've got to believe one of these three things. Either the Bible is all false, or it's all true, or some of it's true and some of it's false. And if you reject two of those things, then by default, you'd have to believe the third. So he says, in view of the importance and prominence of the Bible, a man who is seeking truth will fairly face the responsibilities of affirmation and at least determine for himself what is the most reasonable conclusion with regard to such an issue. In the first class, we started out by saying that the one thing that Christians and atheists, that Christadelphians and atheists have in common is this, that we both care an awful lot about truth. There are a lot of people that don't fit into those categories, agnostics, who think that maybe there is no universal truth. But atheists reject that idea. They believe in an absolute truth, just like we do. But we differ on what that truth might be. And so now we're going back into the sciences to have a look at that. And we talked about science in the first class, and I'll talk about it again now. You see, science began because men believed in a God. They expected that when they looked at the natural world, they would find law and order because they believed in a lawgiver. If we had never believed in God, then science as we see it today may have never existed, because we expected we'd be able to make sense of the world. And Albert Einstein wrote in his book, Physics and Reality, the most incomprehensible thing about the universe is that it is comprehensible. Now, he had a friend named Maurice Solovine, and Maurice Solovine wrote him a letter, and he said, "What did you mean when you said that?" And Albert Einstein wrote him back, and this is what he said. He said, "You find it strange that I consider the comprehensibility of the world, to the extent that we are authorized to speak of such a comprehensibility, as a miracle, or an eternal mystery. Well, a priori," which is a Latin term that means without prior knowledge. If we didn't have any other evidence, one should expect a chaotic world, which cannot be grasped by the mind in any way. The kind of order created by Newton's theory of gravitation, for example, is wholly different. Even if a man proposes the axioms of the theory, the success of such a project presupposes a high degree of ordering of the objective world, and this could not be expected without prior knowledge. This is the miracle which is constantly reinforced as our knowledge expands. I imagine Richard Dawkins is a little bit uncomfortable that Albert Einstein was throwing around words like miracle when talking about the nature of the universe. But do you see his point? The very fact that we can actually comprehend the world, that we can make sense of it, that we can explain the mechanics behind how it works, seems impossible. It seems crazy. If, in fact, we got here by a series of chaotic random events, how are we here with minds capable of understanding things that are lawful and orderly? And yet, as we look into every avenue of the sciences, we're able to write it down on a page to make sense of it. How could that be the case if there was no God? And interestingly enough, around the world, throughout human history, we have continue to discover more and more every day and every year, a language that was not created by humans, that was always in existence. And it doesn't matter what other human language you speak. If you're a mathematician, you speak the language of mathematics. Now, this man's name is Paul Davies. I'll say something I said in the first class. I'm not a scientist, and I think that's important to tell you. And I'm not an expert in some of these fields that we're talking about in the sciences. And I think it's important to have a look at what people who are at the front of their fields have to say about them, because it's easy for you and I to say, oh, well, that makes sense to us, but there are a lot of things we don't know about the sciences. Do the people who are actually at the front of their fields, are they saying the same kind of things? This is what I want to show you, that the people who are at the cutting edge of what we know about the world around us really are coming to some of these same conclusions. Now, this man is a physicist, Paul Davies, and he's written a lot of books. He's agnostic, but a lot of his books have been quoted by Christians quite often because of the kind of things he says in them. Things like this. He wrote in his book, The Mind of God, in 1992, just because the sun has risen every day of your life, there is no guarantee that it will rise tomorrow. The belief that it will, that there are indeed dependable regularities of nature, is an act of faith, but one which is indispensable to the progress of science. So here's a point he's making, that faith is just as much a part of science as it is a part of religion. Science is based on being able to do a test, see it happen, see it be the outcome, look a certain way, do it again, see the same thing again and again and again, every time we do it, until we're satisfied that this is always going to happen this way. But the reality is, you never know with 100% certainty that it actually will until it happens. Just because the sun has risen every single day of your life is not proof 100% that it will rise tomorrow. You won't know that till you wake up in the morning and see it. And so it is with science. You have faith that because something's happened this way every other time, it will happen again. So faith, he says, is also an important part of science. Now, John Polkinghorne is very well known for being a physicist who put his scientific hat aside and became an ordained priest. And ever since then, he's been his role that he sort of made for himself has been sort of like an ambassador between religion and science. And he wrote in his book, Reason and Reality, he said, "Science does not explain the mathematical intelligibility of the physical world, for it is part of science's founding faith that this is so." Everywhere we look in every single avenue of the sciences, we use math to decipher the things that we're looking at. How could this be the case? How can this language be governing everything that we see? He says we can't explain it, we don't know why, so it's part of the scientific faith that it's just this way and it always will be this way. Eugene Wigner won a Nobel Prize in physics, and despite his work in the field of physics, his most famous thing that he published was a paper called The Unreasonable Effectiveness of Mathematics. Back in 1960, he wrote, "The enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious, and there is no rational explanation for it. It is an article of faith." Paul Davies, again, who we quoted before, He says much of the mathematics that is so spectacularly effective in physical theory was worked out as an abstract exercise by mathematicians long before it was applied to the real world. What he means by that is this. Throughout the history of mathematics, mathematicians have discovered whole new avenues of math and new formulas that continue to build on each other. And they had no purpose at that time. It was all just theory. And when they discovered it, it wasn't useful to them at all. And time again, eventually, somewhere down the road, in one avenue or another of the sciences, they realized these formulas that we discovered a long time ago actually are governing this aspect of the universe that we live in. And they had no idea. They weren't able to put those two together until eventually they realized, oh, wow, these formulas really do have a purpose. They are part of the laws of nature. And Paul Davies says that's happened again and again and again. We come up with these formulas, and it's not until sometimes generations later that we realize they actually are somehow governing the world that we live in. And Savas Dimopoulos, this is from that documentary I told you about in the first class last night, Particle Fever, about the discovery of the Higgs boson. So one of the world's leading physicists. He was the mentor of that other young scientist, Nima Arkani Hamed, who we quoted from about the cosmological constant in the first class. This man was his mentor. And he said in the documentary, it's astonishing that there are any laws of nature at all, that they are describable by mathematics, that mathematics is a tool that humans can understand, that the laws of nature can be written on a page. It's the greatest of all mysteries. You see, as a species, we started out doing science because we believed in a God, a lawgiver, and we expected to find laws in place. And generation after generation, scientists have discovered more and more laws that are governing the world that we can live in a language that we can understand, but that we didn't come up with, that we only continue to discover. He says it's the greatest of all mysteries that this should be so, that we could actually write down the laws of the universe on a page. Now come with me to John chapter 1. And a lot of you will know this passage very well. I'm going to start reading from verse 1. John chapter 1, starting at verse 1. In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things were made through him, and without him was not anything made that was made. In him was life, and the life was the light of men. The light shines in the darkness, and the darkness has not overcome it. Now, over and above all of the theological meaning that we often go into when we read these verses, there's a simple application of these passages too, of these verses. That word for word in the Greek is the word logos. It simply means language. In the beginning there was language. It's as if God used language to create all things. If you were to turn to Genesis chapter 1, just go through that whole chapter of the creation account and count how many times it says, "And God said," over and over again, as if God was using language to create the world and everything that we know. And you know, in all of human experience, there's only ever been one thing that is capable of creating a language, and that's a mind. And here in mathematics, we have a language that we did not create, that we only discovered, and we continue to discover more of it every single day. And we discover, too, that it governs all of the laws by which this universe exists. We see it in DNA. We looked at genetic code in the first class, and we realized that the very code that we're made of is like a very complex language, the human genome, 3.5 billion letters long. We see it in the universe. We see the cosmological constant, which has to be an extremely precise number. If it was anything else, the universe would either fly apart or collapse in on itself. Everywhere we look, we see a language that we didn't create, that was already there. And the only thing that we know of capable of creating a language is a mind. And we read all about that mind right here in our Bibles in front of us. Now, when I first gave this series of classes, it was back at the end of 2014. And on December 25th in 2014, I was given a present right in the middle of these classes in the form of an article in the Wall Street Journal. Looked like this. Science increasingly makes the case for God. I couldn't believe it. This was the Wall Street Journal. It's written by a man named Eric Metaxas. And Eric Metaxas, I went on to read about him. It turns out he's a pretty well-known Christian apologist, and he wrote this piece for the Wall Street Journal, which is a major publication. I was surprised to see a Christian apologetic work here in such a major mainstream publication like the Wall Street Journal. And he published this article, and about a month later, a very well-known member of the New Atheists named Lawrence Krauss, who's a physicist, published a rebuttal to this article. And he tried to publish it in the Wall Street Journal, and the Wall Street Journal refused, so he went and published it in the New Yorker instead. I think it's the New York Times. And both of the articles are really interesting. The first article, Science Increasingly Makes the Case for God, and the rebuttal article by the atheist Lawrence Krauss. And we're going to look at that a little bit after we look at this article first. This article, you can go online and read it right now. You can just search for Science Making the Case for God in the Wall Street Journal, and you can go right there and read the article. It's not very long. In the first few days of its publication, it received more comments online on Facebook than any other article that had ever been published by the Wall Street Journal. And I went on and just browsed through some of those thousands of comments, and you find it was a hotbed of controversy, of people going back and forth, atheists and Christians, and just taking shots at each other in the comment section of this article. And so I want to talk about it for the next few minutes, because what it said I found very interesting and strengthened my faith quite a bit. We're not going to read the article itself. I will show you a clip from it in a minute. We're going to actually get into what it says in a lot more detail than the article itself does. And it starts by taking our mind back to a time in history. The year was 1966. 1966 was the year of probably the most famous cover of Time magazine that was ever published. This one right here, Is God Dead? It was the first time Time magazine had ever published one of their magazines that didn't have a photo on the cover. It just had this black background. And without even reading the content of this magazine, many people were up in arms just from the title. It was the most well-read article of Time magazine ever. It received more letters to the editor than any other issue of Time magazine ever had at that time. And it itself was very controversial. If you were to go and read it, you'd find it may not be quite what you think. It was more a critique on the state of Christianity at the time. It was saying that within Christian culture, there are actually at Christian universities, there are professors and there are even priests and pastors who are now teaching that God is dead, that God is no more, within the Christian religious movement. And that Christian numbers in their churches are dwindling, and things are changing, that the God of the Bible is no longer appealing to people. And so they make some recommendations in the article about what Christianity could do to stop its membership from dwindling. Things like talk less about God and talk more about Jesus and how that applies to you personally. Stuff like that. So he refers us to that article in Time magazine in 1966. And in that very same year was when, as a culture, we first started to become aware of, at least by hearsay, sightings of UFOs. And now we kind of look at this with a lot of skepticism, but back then this was a big deal. People thought that we were seeing alien spaceships in the sky. This was not a thing before 1966, and people were very afraid of it. And the government took it seriously. Now, in fact, those were all hoaxes, the actual seeing UFOs in the sky, but it was something that was very much a hot topic and had people talking. A lot of people were scared. And the government set up a task force called SETI, which stands for the Search for Extraterrestrial Intelligence. Now, trust me, this may seem off topic, but we're going in the right direction. This will all tie in eventually. You'll just have to believe me. So, scientists turned their eyes and ears to the sky to listen for a message from extraterrestrial civilizations because they believed that it was only a matter of time, that there must be life out there. And there was one man on this task force. His name was Carl Sagan, and he would become the great ambassador to the masses for science. And he would have his own television program called Cosmos, where he would explain all that we knew about the universe so far. And he would be a looming figure in science. And he said that there are only two criteria for a planet, any planet, anywhere in the galaxy or the universe, to be able to support life. Just two criteria: the type of star in the solar system and the proximity of that planet to that star. So I'm going to play you a video clip now from that program, Cosmos. You'll see Carl Sagan. You'll see what people thought at the time about whether or not there was actually other life out there on other planets. And I'm hoping the sound is working. We'll start playing here. If it doesn't work, I'll do the microphone thing again like I did last night. Here's Carl Sagan in Cosmos.
This is one of the great questions. How many advanced civilizations capable, at least of radio astronomy, are there in the Milky Way galaxy? Let's call the number of such civilizations by the capital letter N. It's a number. It depends on many things. It depends on the total number of stars in the Milky Way. Let's call that N sub star. It depends on the fraction of stars that have planets. Let's call that F sub p. It depends on the average number of planets in a given solar system that are ecologically suitable for life. Let's call that N sub e. Depends on the fraction of suitable planets in which life actually arises. Call that F sub L. Depends on the fraction of inhabited planets on which intelligence emerges. Let's call that F sub I. And on the fraction of those planets in which the intelligent beings evolve a technical communicative civilization, call that F sub C. Finally, it depends on the fraction of a planet's lifetime that's graced by a technical civilization. Call that F sub L. If we multiply all these numbers together, we've estimated capital N, the number of civilizations. This equation, due mainly to Frank Drake at Cornell, is only a sentence. The verb is equals. So let's try to go through the program of this equation. By carefully counting the number of stars in small but representative regions of the sky, we find that the total number of stars in the Milky Way is about 400 billion. It's a lot of stars. What about planets? Well, in studies of double stars and investigations of the motions of nearby stars, and in many theoretical studies, we get a strong hint that many, perhaps even most stars, are accompanied by planets. So let's take F sub p, the fraction of stars that have planets, as a quarter. If we were to multiply all these factors together, we would find 100 billion times a 10 times a 10, or 1 billion planets on which civilizations have arisen at least once. Now, what percentage of the lifetime of a planet is marked by a technical civilization? The Earth has harbored a civilization capable of radio astronomy only for a few decades, the last few decades, out of a lifetime of a few billion years. It's hardly out of the question that we might destroy ourselves tomorrow. If that's a typical case, then F sub big L would be a few decades, or a few billion years, or 100 million, a very small number. And then big N would be a billion times 100 million, or N maybe just 10 civilizations, a tiny smattering of pitiful few technological civilizations in the galaxy. But civilizations then might take billions of years of tortuous evolution to arise, and then snuff themselves out in an instant of unforgivable neglect. If this is a typical case, there may be few others, maybe nobody else at all. burst apart. But consider the alternative, that if civilizations learn to live with high technology and survive for geological or stellar evolutionary timescales, if only 1% of civilizations can survive technological adolescence, then that's a big L. Would be not 100 million, but only 100. And then the number of civilizations would be 1 billion times 100. The number of civilizations in the galaxy then would be measured in the millions. Millions of technical civilizations.
So this is what they believed. There must be millions of civilizations out there right now on other planets just in our galaxy, which means that it would only be a matter of time before we made contact with one of them. So we built great satellites, and we waited for some kind of communication, and we turned our telescopes to the sky. For decades, we listened and heard nothing. But something else happened over those decades, too. So this is a quote from this article from the Wall Street Journal at the end of 2014. Eric Metaxas writes, "Today, there are more than 200 known parameters necessary for a planet to support life, every single one of which must be perfectly met or the whole thing falls apart. Without a massive planet like Jupiter nearby, whose gravity will draw away asteroids, 1,000 times as many would hit Earth's surface. The odds against life in the universe are simply astonishing. Yet here we are, not only existing, but talking about existing. What could account for it? Can every one of those many parameters have been perfect by accident? At what point is it fair to admit that science suggests that we cannot be the result of random forces? Doesn't assuming that an intelligence created these perfect conditions require far less faith than believing that a life-sustaining Earth just happened to beat the inconceivable odds to come into being?" So here's what happened. At first, we thought, back in the 60s, that there were only 2 criteria necessary for a planet to be able to support life. You remember I mentioned those: the type of star in a solar system and the proximity of a planet to that star. But then scientists discovered more parameters necessary for life. And they discovered more, and they discovered more as the years went on. And the more parameters they discovered, the more that probable number of other planets out there with civilizations on them started to shrink. It got smaller and smaller. The more things we discovered that were necessary, that had to be just right for life to arise, to the point where it got to a 0% chance that there are any other civilizations out there. And then we kept discovering more criteria for life. And then the probability that we should ever even exist got smaller and smaller and smaller until it became basically an impossible situation, except for the fact that we're here for some reason, that we should be here. That there's a planet anywhere, in a universe somewhere, that supports life. The fact that we're here became a miracle. And Eric Metaxas mentions over 200 parameters now that have been discovered necessary to support life in the galaxy. Now, I searched and I couldn't find anywhere near 200, and that's one of the things that he came under fire for in this article. He throws out that number of 200 parameters, but nobody can find it anywhere. I did find a good list of 22 different parameters necessary to support life on any planet in our galaxy. And we're not going to look at all of them, but I'm going to just show you a few of them so you get sort of a sampling of the kind of things we're looking at. So, for example, we have the gravitational force constant, which is a large-scale attractive force. If it's too weak, then planets and stars can't form. If it's too strong, then stars burn up too quickly. There's the electromagnetic force constant. If it was much stronger or weaker, we wouldn't be able to have stable chemical bonds, and hence no life on the planet. There's the strong nuclear force constant. If it were weaker, the universe would have fewer stable chemical elements, including several that are necessary, that are essential for life. There's the one that we talked about last night, which is just one of many, the cosmological constant. You remember that, right, in Einstein's field equation? It has to be very close to 0, but not 0, because we now know that the universe is expanding and it's accelerating in that expansion. And if it was any other number than what it is, then the universe would either fly apart or collapse in on itself. And we'll skip forward a bunch here. Within the solar system, there needs to be a large moon around the planet with the right planetary rotation period, which establishes the right gravitational pull so that, for example, our Earth, our axis is on a 23.5 degree angle, which is just perfect to ensure relatively temperate seasonal changes so that the Earth can support complex living organisms. Within the galaxy, the solar system would need to be near the edge of what's called the circumstellar habitable zone. Within the solar system. If the Earth was just 5% closer to the Sun, the Earth would be just a lot like Venus. Of course, no life could exist. And conversely, if it was just 20% further away, then the Earth would be a sterile environment like Mars, also incapable of supporting life. And now, this is the one about the galaxy. The solar system has to be within the right zone of the galaxy because the center of the galaxy and anywhere close to that is way too dangerous to support any kind of life on any of the planets in any given solar systems. And so the very fact that we're here, that life exists on this planet, is incredible. It beats the odds by a significant margin. And all of those parameters had to be exactly what they are for us to be here. This is what is referred to as the fine-tuning of the universe, and we only started describing that when we talked about the cosmological constant last night. There are so many parameters that had to be set just right in order for us to be here. It begs the question that Nimar Khani Hamed mentioned last night. Doesn't it seem like there must be somebody who set all of these parameters at precisely the right value so that we can be here now? Now, I mentioned that there was a rebuttal article written and published by Lawrence Krauss. And I want to talk about that a little bit now, too. I think it's always important to get the fully rounded picture. If somebody's saying something like Eric Metaxas said in the Wall Street Journal, then what was said in response to that? It was the New Yorker, not the New York Times. I was right the first time. So at the end of January, about a month after the first article was published, Lawrence Krauss published a rebuttal. And the title, you might be able to see up here on the screen, the title is No, Astrobiology Has Not Made the Case for God. And just like the first one, we don't have time to go through the whole article, but I want to touch on some of his major arguments. And the first one, I'll show you in just a second. Lawrence Krauss is sort of ridiculing the Eric Metaxas argument by coming up with a real-life scenario where he says, I could come up with any kind of scenario where the odds of something happening are improbable or maybe even virtually impossible, and yet here we are. And he gives an example. He says, in order for me to be writing this piece at this precise instant on this airplane, having done all the things I've done today, consider all the factors that had to be just right. I had to find myself in San Francisco among all the cities in the world. The sequence of stoplights that my taxi had to traverse had to be just right in order to get me to the airport when I did. The airport security screener had to experience a similar set of coincidences in order to be there when I needed her. Same goes for the pilot. It would be easy for me to derive a set of probabilities that, when multiplied together, would produce a number so small that it would be statistically impossible for me to be here now writing. I'm just going to pause there for a second. We'll go on. I never saw anybody point this out, but this struck me as odd that this world-renowned physicist and atheist would use an argument like this one. Because the very point of the Eric Metaxas article in the Wall Street Journal is that the fact that we're here in a planet, in a galaxy, in a universe that's capable of supporting life has beat the odds. It's impossible unless we acknowledge there is intelligence behind it all. And the example that Lawrence Krauss gives here, well, certainly the example that he gives would seem impossible if he was a rock and didn't have a mind. And so is the taxi driver, and so is the security screener, and so is the pilot. If there was no conscious, intelligent force behind this story, then it would make sense. But the point is that every step of the way in his story, he woke up in the morning with a plan, and he needed to get on the airplane and write that article. Everybody else along the way all had their own plans to pick him up, to screen him at the airport, and to fly him to where he needed to go. There is a mind behind every individual in this story. Yes, it would seem impossible. The odds of it would seem impossible if there was no intelligence behind it all. But as soon as you put individuals into this story, it doesn't seem impossible at all because there's intelligence involved. And so far from disproving the original point, it makes it even stronger. Because if all of these people were just inanimate objects and he happened to end up on an airplane flown by an inanimate object, yeah, sure, that would seem impossible. But that's not the case at all. And you see the point? I'm surprised that I never saw anybody call him out on that part of the article. Now, he goes on to say, it is true that a small change in the strength of the four known forces, but nowhere near as small as Metaxas argues. So Lawrence Krauss is a physicist, Eric Metaxas is not, and he really calls him to task for this, would imply that stable protons and neutrons, the basis of atomic nuclei, might not exist. Maybe not. And that part, he's saying, it might be true. The universe, however, would. A rather large error in the Metaxas piece. Now, by the way, this was not the point. The point was not that the universe wouldn't exist, it's that it wouldn't exist like we see it today. It wouldn't be capable of life. It would be a series of random chaotic forces where life couldn't exist. And he says, but we knew this already. This is old news. And while it's an interesting fact, it certainly does not require a deity. Now, once again, I'd say, I hate to dismiss him so quickly here, but just the fact that it's old news and everybody knows it doesn't make it any less true. But he says it anyway. He says the null hypothesis is most often the default hypothesis in science. Now, the null hypothesis says if you see two things and they seem to be closely related to each other, it seems to be, this thing that you see happen seems to be, really incredible, your first instinct, your first hypothesis should be that it's simply a coincidence. You must assume immediately that this is just a coincidence. We reject, he says, the null hypothesis only when we have clear evidence to back it up. Or, as Carl Sagan often repeated, extraordinary events require extraordinary evidence. Surely the God hypothesis is extraordinary in the extreme. And the entire point of these classes is to show you the opposite. That belief in a God is actually the most logical, reasonable thing to believe. That when you examine the evidence, that's where it leads you. If you're truly interested in truth and you're following the evidence wherever it leads, then those who are intellectually honest with themselves will see the stamp of the Creator when they look at the creation and when they look not just at the Bible, but within the book of nature that God has given us as well. And one of the questions that Richard Dawkins asks in his book, The God Delusion, is this, or one of the points that he makes. He says, if you're going to tell me that there's a God that created everything, he says, then I have the right to ask you the question, who created that God? And of course, the Bible tells us nobody. God is forever. He is eternal. He has always existed. And I don't know about you, but ever since I was little, that has just completely overwhelmed me. I can't even begin to comprehend something having been always in existence. And so the point that Richard Dawkins makes rings home to me. I struggle with that. How could there have been a God that was not created, that has always been in existence, until I realized the truth of the matter? You see, if it's fair for Richard Dawkins to ask the question, who created God, then think about this. If you don't believe in God, then you believe in something. You believe that matter has always existed. Perhaps you believe in the Big Bang. And that's when matter from its very condensed form exploded and became the universe that we see today. And even if you don't believe in God, you believe in matter that has always existed. So if there's no God, then matter has existed for eternity. And I'd have the right to ask you the question, who created matter? Because no matter what you believe, the very fact that we're here means that we're faced with the reality that something has lasted forever, for eternity. And as hard as that is for us to comprehend now in our current mortal state, we realize that must be true. And we realize that no matter what position you take, whether you believe there is no God or whether you believe there is a God, we live in a world that we cannot begin to comprehend because we live in a world where something has always lasted forever. And it's no more ridiculous to believe that God has no beginning or no end than it is to believe that matter has no beginning or no end. But we know that one of those things is definitely true. So the question becomes a moot point. Now, within science, and outside of science too, there's a principle called Occam's razor. But before we get there, I want to show you a quote from Fred Hoyle. We'll talk a little bit more about the fine-tuning of the universe. Now, Fred Hoyle is the scientist who coined the phrase Big Bang. He came up with it. At the end of his career, he decided he didn't like it anymore. He stopped believing in the Big Bang, but nevertheless, he was an atheist for his whole life and died an atheist. But he's perhaps most famous for saying this. He did some groundbreaking work within his field, and he found at one point that his faith as an atheist, he had said, was greatly shaken. He said if you wanted to produce carbon and oxygen in roughly equal quantities by stellar nucleosynthesis, this is where he did his work, which would explain the origin of life, or how we're here, these things have to have happened for life to exist. These are the two levels you would have to fix, the levels of these two quantities, and your fixing would have to be just where these levels are actually found to be. A common sense interpretation of the facts suggests that a super-intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. This man remained an atheist, but he said this is the kind of thing, like the earlier quote we saw, that kept him up at night, that shook his faith like nothing else had ever shaken his faith. His faith, in fact, that there is no God. He said just by looking at it, it would seem that there must have been an incredible intellect behind it all. And Paul Davies, that man who we quoted much earlier, the physicist, wrote, "There is for me powerful evidence that there's something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design," he says, "is overwhelming." This man is actually a Quaker, so he is religious. He does believe in God. He co-published a book with Stephen Hawking before he died. George Ellis wrote, "Amazing fine-tuning occurs in the laws that makes this complexity possible. Realization of the complexity of what is accomplished makes it very difficult not to use the word miraculous without taking a stand as to the ontological status of the word." And Arno Penzias, also, another man who won a Nobel Prize in physics, he said, "Astronomy leads us to a unique event, a universe which was created out of nothing, one with the very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say, supernatural plan." My point in showing you these quotes is to say, yes, I'm not an expert. I'm not a scientist. I don't study in these fields. Here's what the experts have to say. Some of them agnostic, some of them atheist, who nevertheless have to begrudgingly admit that everything we've seen seems to lead to the same conclusion, that there must be a mind behind it all. Now, in the sciences, Occam's razor is a phrase that originally is attributed to William of Ockham back in the 12th century. You see it in the Latin up there. Here's the English interpretation of this. "It is futile to do with more things that which can be done with fewer." Now, most scientists that have ever existed have applied this sort of philosophy in general in their work. For example, here's a similar quote by Isaac Newton. "We are to admit no more causes of natural things than such as are both true and sufficient to explain their appearances." So what they mean by that is this. In the sciences, scientists in all fields will look at phenomena in the natural world, and they'll try to come up with theories to explain it. They'll say, what could explain what we see right now? And to be a scientist, you have to go through the scientific method, which is to come up with working theories and then find a way to test those theories, perhaps in a lab somewhere. So you perform the test, and you see if it makes sense, if it plays out the way you think. And you go back to the drawing board. Usually you'll come up with a whole bunch of theories at once. You'll go through a brainstorming session. What are all the various things that could describe why this is happening? Occam's razor says something like this. When you've got a bunch of theories and none of them have evidence to support them any more strongly than any others, then you've got to go with the one that is the simplest, that requires the least amount of explaining, because that one is the most likely to be true. And new atheists like Richard Dawkins have used Occam's razor to say that belief in a God is ridiculous because to explain humanity and life on this earth and the whole universe, you are theorizing a being that you call God, who by definition would have to be more complex than the thing that he created in order to create that thing. He says, by simple virtue of the scientific practice of application of Occam's razor, we should rule that possibility out. Because you're theorizing something far more complex to explain something far less complex. But the important thing to understand about Occam's razor is that it only applies in a situation where all things are equal, and one theory doesn't have any more evidence than another. In fact, throughout the history of science, we found that if we were to only use Occam's razor in that case, we would have gone far wrong. So let me show you, this is the last video clip I'll show you in this series of classes. This is another clip from the debates, one of the debates that we listened to last night between Richard Dawkins, the atheist, and John Lennox, the professor of mathematics, also at Oxford University, where Richard Dawkins comes from. And this is one of his two debates with Richard Dawkins.
As he suggested that introducing God would mean an end of science. God is no explanation, since by definition God is more complex than the thing you are explaining. Now, this, he states, is the central argument of his book. I would not have expected an argument like this from a scientist, because explanations in science themselves are usually in terms of increasing complexity. An apple falling is a simple event. The explanation in terms of Newton's law of gravitation is already stretching the minds of many people. But its explanation in terms of a warp in space-time is stretching the minds of the cleverest. Simplicity isn't the only criterion of truth. Let me give you an example. Suppose you're an archaeologist, and I'm exploring a cave with you, and you're a Chinese expert, and on this cave you see two scratches. And you say, human intelligence, and I say, pardon, they're just two scratches. And you say, but those are the Chinese character run, which means a human being. And I say, look, Richard, that's no explanation at all. You're postulating something as complex as a human brain to explain two scratches. That means that your explanation is more complex than the thing you're explaining. That's no explanation at all. Now, it seems to me that's exactly what you're saying in your book.
Now, I really like that analogy, and it applies directly to what we've talked about in this class. Did you follow it through? He's attacking that idea that we should be able to dismiss the belief in God simply because God would have to be more complex than the thing that he created. It would require more explanation than simply thinking that we came here, perhaps, randomly. He says, but look, let me give you another scenario. If you and I were exploring and we discovered a cave, an ancient cave with two scratches in it, but they were symbols, they were characters, and you know the ancient Chinese dialect. You recognize this as language. And you say human intelligence, but by your same logic, applying that same principle there, you'd have to say, no, you're theorizing something as complex as a human being just described two scratches? Because since the beginning of our existence, or at least from very early times, we have, as a species, discovered a language, more and more as history has gone on, a language that we didn't write, that nevertheless seems to govern every aspect of the world in which we live. And as I said before, there's only one thing in all of human experience that we've ever encountered that's capable of creating a language, and that's a mind. And I hope at this point in our discussions, you'd agree with me that there is absolutely extraordinary evidence everywhere that we look, and not just for the existence of God, but for the truth that Jesus was the Son of God, for the truth that God can and will resurrect us from the dead. And in the next class, we're going to ask the question, but what evidence do we have that this that we have here in front of us really is the inspired word of that God? So that's where we'll be going next in the last class today.